Thank you everybody for joining. This is my presentation. The title is The Voices of Water, Development of a PGIS System for Spatio-Temporal Water Quality Monitoring in the Doña Juana Volcanic Geoecosystem at Nariño, Colombia. Okay, so this is a brief agenda of what we'll be covering today. And first, the introduction, what's this project about? So it's about the development and implementation of a PGIS system for water quality monitoring in the Doña Juana volcanic ecosystem at Nariño, Colombia. It integrates local knowledge systems that the community has around 4 different water types and measure three parameters, which are pH, dissolved solids, and temperature, integrating them in a web-based GIS system. First, the study area and context. We are located around the Doña Juana volcanic complex in the central cordillera of Colombia in southwestern Colombia, around the municipalities of La Cruz and San Bernardo. About a brief volcanic history of the volcano. It has more than 6,000 years of activity, and the last eruptive cycle was around 1897 and 1936, called locally as La Derrota, in English, the defeat. In this map, you can see that the study area encompasses the Natural National Park, Doña Juana Cascabel, and Las Mesas, which is the main populated zone. Also, people habitate in the main villages that you can see in black on the map. So first, I want to talk about the 4 traditional water classifications. The first type is Mudas waters, in English, silent waters. These are clear, tasteless, and odorless waters, interpreted as shallow meteoric aquifers with a high water table. They are used for drinking and daily use in El Silencio village. Second type is Organicas water, forest scent waters. This water is rainwater filtered through forested slopes and serves 500 families in El Plan San Rafael aqueduct. The third type is Tibias waters, which is warm waters. They have an elevated temperature and are part of the hydrothermal systems of the volcano in the study area. Finally, the Gordas waters, or greasy waters, are characterized by their orange hue and deep hydrothermal waters that are also part of acid alteration zones. They are not used, but it is important to mention that Gordas water shift their location geographically around the study area due to terrain changes. And okay, so why monitor water in these areas? First, they can be a possible indicator of volcanic activity. Sudden changes in temperature, pH, or dissolved solids can signal volcanic activity and can help as early warning systems for timely action. Second, environmental and community relevance. It is important that communities engage in the water sources that they depend on and they can monitor them, gaining greater local territorial autonomy and also signaling possible anthropic contamination. Now, the objectives of this project were to build an spatio-temporal database to record these properties in water, engage local communities in the data collection process, develop a real-time web application to show the results, and strengthen the links between scientific and traditional knowledge systems for water monitoring. And finally, the question involved how this environmental knowledge could be integrated into a water monitoring system that uses modern geospatial technologies in ways that were meaningful, accessible, and empowering for local populations. So the methodology used in this project involved multi-parameter probe. The reference is EC9901, and this probe measures 3 main parameters. The first is temperature, which indicates hydrothermal and possible volcanic activity, pH, that signals acid changes, and total dissolved solids in parts per million that show possible water-rock interaction, and chemicals and physical components integrated into the water composition. Second, a PGIS system was designed with 3-tiered architecture. First, a geodatabase was designed in ArcGIS Pro and published as a feature service. It included mainly a point layer, which served for the water sites. Then this layer was used for a web map and the second point, which is the mobile data collection in field maps. And a form was designed that allowed offline data collection with automatic synchronization, and finally, a web visualization to present the results in ArcGIS Experience Builder. It can be interactive between 2D and 3D views, showing charts with the variations of pH, temperature, and total solids across time. This is an overview of the data schema of the geodatabase. Relevant fields were configured for each parameter. Attachments and date fields were also enabled. Subtypes in the second part were configured, and also coded domain values that represent the local water classifications. Second, this is the data form in ArcGIS field maps. It was given with brief instructions in Spanish for the data collectors. And finally, the web visualization in ArcGIS Experience, which shows 2D and 3D frames and charts to show the results across time. Now, the selection of community monitors was based in 3 groups mainly. The first group is composed by Don Jesus Irua, or called Don Chucho. He has 50 years of territorial knowledge and is board member of El Plan San Rafael Aqueduct that serves 500 families. He conducts weekly inspections and is a local leader in protection and land stewardship. Second group is confirmed by Leonardo Martinez and Wilfer Muñoz, which are National Natural Park Rangers that patrol the protected area 10 times per month. And finally, the National Natural Park Ranger, Alfonso Vivas, which is in charge of environmental education and communication, who works with rural schools and also indigenous communities in the study area. Once the actors were selected, we designed a 3-phase participatory training methodology. The first part included a collaborating learning approach, which included field visit to the water sources, demonstration of the probe operation, and field maps data entry. Second, it was based in independent practice. Each monitor performed alone the data collection, and if they had questions, we helped them on the process. And finally, peer teaching. Each monitor trained another person, and that showed knowledge multiplication and ownership of the process. Finally, a supporting material, which is an 8-page laminated field guide in Spanish, was customized for each monitor group and shared with them. A WhatsApp group is also available if they have questions or issues around the troubleshooting of the application. So here are the results of El Plan San Rafael with Don Chucho. We can see around 4 stages of the aqueduct, around the source, the sand filter, the storage tank, and the treated water. We can see consistent pH values and low total dissolved solids, and a temperature depending mainly on environmental temperature. The second part of the results involves the National Natural Park Rangers, and we found first a group of Muras waters with a very neutral pH, very low total dissolved water concentration, and 2 groups of tibias, one alkaline type with a slightly higher pH, close to 7.6, and higher total dissolved solid concentration. Also a near neutral type of tibias water in the third point. And finally, Gordas water near the Humadal stream, which showed acid pH and also a slightly elevated total dissolved solids, showing hydrothermal alteration zones. Finally, the results of the community extension with Alfonso Vivas included a first result in El Paraíso Spring, which was a hydrothermal spring measured by the Colombian Geological Survey in 2011. This was the most astonishing result of the project, which showed a very low pH, a high temperature of 57 degrees Celsius, and 2,856 parts per million in dissolved solids. This is a thermal spring of the Animas volcano and was started by the community. Also, De La Cruz Community Aqueduct was measured with help of Alfonso, and De Las Animas Village, Gordas water, were also measured. They showed high temperature and also high total dissolved solids concentration. And the results are available in the Experience Builder platform in the link that is at the bottom. I will share it later with you, and features the monitoring points that is constantly growing with automatic updates from field collected data. And you can interact with the Experience Builder platform, toggling into 2D and 3D views, and interacting with the charts. The conclusions is basically what did we learn from each water type and what did they told us. So first, the Mudas waters are like a baseline reference of clean meteoric water. The pH is almost neutral, 7.01. It had the lowest temperature and minimal total dissolved solids. However, they represent a challenge due to their remote location, and it will be fixed with a need of local monitors in El Silencio village. Then we have the Organicas, which showed an effective management by El Plan San Rafael board. They showed consistent total dissolved solids and also near neutral pH. The temperature follows the ambient conditions, and it was a successful implementation since it empowers Don Chucho and the aqueduct board to manage sustainably the aqueduct and the water. Third, the Tibias water showed an early warning potential, since they have variations in pH and temperature that can signal possible volcanic activity. pH drops or temperature increases could signal unrest and can serve as early warning systems. Finally, Gordas water are also a structural and hydrothermal indicator. Variations in their pH can also signal volcanic activity, but they have something special also because they vary, especially in the study area. So tracking them can also show structural changes, landslides, and other relationships in the study area. And finally, this is an overview of the project. It was a successful integration of a system that merged the traditional classification with modern geospatial technologies. It empowered participation by the community, ensuring the sustainability and ownership of their data. It's a knowledge validation that can merge with geochemical measurements and local classification to reinforce stewardship of the community around water, and is an scalable framework that can be applied in many other environments to track landslides, air quality, vegetation, or animals across Latin America and Colombia and the world. And finally, it's an effort towards risk reduction and autonomy by translating the community knowledge into actionable early warning data. So this project seeks to contribute to volcanic risk mitigation and promote territorial autonomy to the Las Mesas community and surrounding villages. And finally, I want to thank especially Don Chucho, whose dedication to defending water and territory stands as a powerful and inspiring example of environmental care. Also thanks to Leonardo and Wilfer from National Natural Parks for working with us through volcanic complex, generously guiding us and sharing their deep curiosity and commitment to nature, and to Alfonso Vivas for becoming part of this initiative, connecting the project with the community and inspiring future generations through his engagement and work towards conservation. Thank you.